Hi, I'm Midhunan. For the data visualization case study, I've taken up the topic COVID-19 social media sentiment and recovery pattern analysis. So this project demonstrates that social media sentiment, mobility patterns and government policies create predictable feedback loops. So why do we have to create this project? The purpose of this project is that by understanding these relationships, we can build better early warning systems and more effective crisis management strategies for future pandemics. So in this project, I have taken 4 different data sets. Those are, I'll open the documentation for the data sets and show you. So there are 4 different data sets used here. One is the COVID-19 tweets data set from Kaggle. It has around 20,000 downloads and it is a reliable data set. And next is the Google Community Mobility Reports. This has all the mobility reports during that time frame. And then we have the Oxford COVID-19 Government Response Tracker. That is also a reliable data set. And then we have the JHU University's CSEC COVID-19 dataset. And what's special about this dataset is that these are 4 different massive datasets which has around 3 lakh tweets, 2.3 million mobility records, and hundreds of thousands of policy and case records. So next we'll get into the notebooks which I've created for this project. So this is the first notebook, which is for the dataset understanding and the exploration. So in this dataset, this is for my personal use, just to understand how these datasets respond, or what are the columns, what are the rows, how it is made up of, and all the details about the datasets. And these are not real important visualizations, but just to make sure that I understand. So I have made these visualizations, and these are it. And also the framework used for these datasets are as usual, like pandas for pandas, numpy, matplotlib, and seaborn to visualize and process the data. And then we have the important data notebook file, which is not directly related to the questions, but this is the NLP pipeline and the text analysis. As we are using Twitter as the data set, Twitter is one of the data set. We have NLP pipeline which analyzes the text and also process based on semantic analysis and a lot of other processes. And there are 6 different stages in this notebook alone. I'm not going to get into the detail of this because we have that 7-minute time constraint. I've given the overview in the project itself. We have the GitHub repo, so you can also refer to the documentation over there for detailed analysis. And then we'll move on to the questions, the research questions. Question 1. Do workplace mobility upticks predict positive lockdown sentiment? So in this we have used a couple of methodology frameworks. The important one is the TLCC analysis, that is the time lag cross correlation analysis. So first we use the load and store the data, load and prepare the data sets, and then a couple of other processes we'll do for the visualization itself. I'll directly go to the visualization. So this is the visualization graph where we show where this is the dual axis plot, where the orange is for the sentiment, orange is for the sentiment and the blue is for the mobility. This cross correlation plot showing the peak at 21 days with a high threshold of 0.392 and then a 95% confidence interval. So this directly relates between the sentiment analysis and sentiment directly leading to the mobility. Then we'll move on to the question 2. So question 2 is which policy combinations trigger lockdown. This is between lockdown fatigue and the compliance pride. We've also used a couple of methodology frameworks for processing the data, and then we'll visualize. I'll directly go to the visualization. So this is basically, once again, so this is a heat map between the stringency, that is low and high, and then the topics, the lockdown fatigue topics, and then the compliance pride topics. So this is a heat map where we also have a legend which depicts the change in topic prevalence. So that is -10, which indicates the dark blue, and -5 is for orange, which is the high change in topic prevalence. So I'll explain one example alone. So in lockdown fatigue topics and with the high stringency, there is high change percentage in topic prevalence. And then we'll move on to the question 3. So question 3 states that can misinformation tweets predict COVID case surges? So this is a very important question because wherever misinformation is predicted, can misinformation lead to prediction of COVID-19 cases? So here also we have used a couple of pre-processing methodologies, and then we will visualize. So I'll directly go to the visualization and show you the visualization. So in this visualization, we show the early warning system where we relate between the misinformation and the case surges. So as you can see, the case surges is marked using the red color, and orange is for misinformation. So wherever there is misinformation, directly it correlates to the case surges. So we can conclude by saying that whenever there is a misinformation, it directly or indirectly increases the cases. Next, we will move on to the question 4. Question 4 says that, do different emotional categories show distinct correlation patterns with specific mobility categories during lockdown? So we have also, to find a solution for this question, we have also used a couple of methodology frameworks to pre-process the data, and then we visualize. I'll directly go to the visualization. So I'll give a gist about the process alone. This is a 6x8 correlation matrix, that is 6 mobility categories and 8 emotions. So this is a direct correlation between each of the emotion and the mobility types. So multiple comparison correction using Bonferroni algorithm, and then pattern recognition through clustering and PCA. So I'll give an example. I'll explain what this heat map is. So basically there are multiple mobility categories mentioned here: retail, grocery, parks, transit and more, and then a couple of emotions as well. So I'll explain one specific cell alone. So this is strong positive, where it leads, where we can conclude by saying that the mobility category parks leads to joy. So there is increased amount of joy in the mobility category parks. So as you can see that in the right side, I've also added the legend, which is the correlation coefficient, where 0.6 represents dark red and minus 0.6 represented by dark blue. And then we'll move on to the question 5. Question 5 is, what was the immediate impact of sharp jumps in the OC, that is the Oxford dataset stringency index, on subsequent mobility reductions in retail and recreation? So to find the solution for this question as well, we have also used a couple of methodology frameworks listed out here, and then we will visualize. I will directly move on to the visualization. So in this visualization, let me take out the visualization. So this is a very simple visualization where the line graph is a average impact, and the interval is plotted using the light violet color. So this graph is between average percentage change in the retail and recreation mobility and the days relative to policy tightening announcement. So the policy tightening announcement is basically the government policies which are taken due to the case surges and the COVID-19 impact. So as you can see, the peak impact is around minus 17.2% at the 14th out of the 14 days. So I'll give a gist about the process alone. So here we have analyzed each of the policy changes, and also this is for 14 days, as I mentioned earlier, and then for each of the number of days completed, the average percentage is being plotted using the line plot. And then we have also used the mark for policy announcement, that is for day 0. This is it for the research question 5. This project explanation, I have just shown the visualization and how we have processed it with a gist. But I have also added all these files into my GitHub repository, where I've clearly detailed about the methodologies used. There is a documentation for the methodology, and then we have then I've created a gist about visualization processes and everything in my README file. I hope if you have any other doubts, we can refer through all this documentation listed. Thank you.